there's another way to solve a system, which is solving by substitution. Now, if you have linear equations, you usually won't use substitution, but it's an important method because if your equations aren't linear, that's pretty much all you've got to go by. So you do need to learn substitution. Okay, so here's our system again. So what I asked the class to do is solve the first equation for y. And people did that. Most people got it right. Here I've solved the equation for y. Here's our equation. Subtract 2x from both sides, divide both sides by 3. You get y equals negative 2/3 x minus 2/3. Or, as one person got, and it works just fine, y equals the quantity negative 2x minus 2 over 3. Either way. So, what do we do with that? Well, what we do, and I'll ask you to do, is take either this form or this form, doesn't matter, of your solution for y, take it into the second equation and substitute it for y. We take it into the second equation because the first equation is the one we solved for y. We wouldn't get any new information by taking this solution back here. All we would get would be an identity and a confirmation that we solved the equation correctly. So we take this solution and plug it into the second equation for y, and we solve that. So do the process. Don't look at what I've got down here. Just go ahead and see what you get. Okay, hopefully you've paused and done that. I chose to use this form. Okay, in substituting negative 2x minus 2 over 3 in for y into this equation, we get this equation. The only difference being that now we have this where the y used to be. Then what do? Well, I've preached this and advised this, and I do all the time, and very seldom do people hear me and develop the habit. When you have a denominator, you multiply in an equation, you multiply through by that denominator, and that gets rid of all denominators in the equation. Then you aren't dealing with fractional expressions anymore. It makes it much simpler. Okay, so here's our equation. We multiply every term by 3, and we get 12x, and we get, well, now I could have divided this 3 by this 3 already, and I would have just gotten negative 5 times this negative 2x minus 2 over 3, which is what I have up here. I chose to multiply the 3 by the negative 5 because I thought it might be a little confusing dividing from here to here. Not sure whether that was a good decision, but it can certainly be done. 3 times negative 5 is negative 15. Then we divide the negative 15 by 3. We're assured that that's going to divide out into a whole number because to get the 15, we'd multiplied something by 3. So the division by 3 has to give us a whole number. And when we do that, and of course we multiply the right-hand side by 3 to get 54. And then when we simplify this by dividing 3 into the negative 15, we have this equation, which we then proceed to solve for x. Very easily done. Distribute through the multiplication here, combine your terms and so forth, and you're going to get x equals 2. And I didn't go through those steps. You should do that yourself to make sure. Then we're going to substitute x equals 2 into the first equation, as we did much earlier, just as we did, and we'll again get y equals negative 2. So having done the substitution and solved to find the value of one variable, you just plug that back into one of the equations to get the second variable. And we could have chosen to solve for x in terms of y, and then we would have substituted our expression for x here. And we could have chosen to solve for y in either of these equations or for x in either of these equations. As long as we substitute into the other equation, that's going to work.